Math 11 problem set 22 explanation. So in this lesson we want to look at graphing complex numbers in the complex plane. We want to find the absolute value of complex numbers, and then we also want to add and subtract complex numbers. So to graph a complex number, you're going to treat the x-axis as the real part as if it's on the x-axis, and then the imaginary part is a number on the real axis. So when we see this, this is going to be like graphing the point -5, -3. So we go to -5 for the real axis, 1, 2, 3, 4, this is -5, and then we find -3 on the imaginary axis, and that would be this point here. That is the point -5, -3. So now here we have a point that's graphed. How do we find the complex number that represents? So this went over to the real part at 5, and it went down to the imaginary part at -3. So this number that we're graphing is the real part is 5, and then we have -3 times I. That's the imaginary part. So that's what this number is. The absolute value of a number is the distance from 0. So if I want to find that, that represents how far this point is from the origin of the complex plane, which is 0 plus 0i, or 0, 0. And now I want to find that. Well, that's really just going to use the Pythagorean theorem for that. This has a length of 5 here and a 3 here. So the absolute value, or the distance, we'll write the distance for that, which is now the absolute value of that point. From there, we're going to simply take 5 squared plus 3 squared. And whether you put the plus or minus there is unimportant. You could put the minus. That would be 5 squared plus 3 squared, and then we're going to take the square root of that. So this is 25 plus 9, that's 34. That would be the square root of 34. If we could simplify that radical, we would do so. But this only has factors of 2 and 17, both of which are prime numbers, so we can't actually simplify that. That distance, though, now is the square root of 34, and that's the absolute value of that complex number. So here we now have this without it being graphed. We're still going to take whatever that number is, and that number is, and square them and take the square root. So the absolute value of this complex number is just 10 squared plus 5 squared. This is 100, this is 25. That will now be 125. If you take 125, you might know what that is, or if you need to do that, that would be 3 5, so that's 5 squared times 5. We can now take the squared number out as 5, and the other one stays inside, so that would be 5 square roots of 5. Then when we want to add or subtract complex numbers, you're going to add the real parts, or subtract the real parts, or add and subtract the imaginary parts, whatever you get by the signs, just as you do when you combine like terms. So this is a plus. We're going to take the real parts and put those together. So that's a 5 plus 2. And then I have a -5i and then a -4i. So if I combine the real parts, that's 6. And then a -5 minus 4, that's a -9i. Here we're subtracting, so we have 2 minus 8i, and then we have minus a minus 6 is plus 6, and then minus that will be a -6i. I'm going to combine the real parts together, that's an 8. I'm going to combine the imaginary parts together, that's a -14i. Here there are 3 parts, so I have 2 plus 7i. I'm subtracting this one, that's a -4i. I'm subtracting this one, that's a -4, and then minus a -6i is a +6i. We're going to find all the real parts, which are just the 2 and the -4. 2 minus 4 is -2. Then I have 7, -4 is 3, plus 6 is a +9i. I would get -2 plus 9i.